Well, I guess it does, but only once. Not multiple times. The last time it happened multiple times.
Yeah.
So I'm pretty sure everything is good.
And the audio's working?
Sorry?
Did you check the audio?
I can check right now. It should be. Yep, it's working.
Okay.
All right. So we got a lot of topics to go over today. Not the master theorem, that's from a morning class, not for this class. So for this class, this is 4.4 is kind of the exact opposite of this class. This is basically going, to the silicon level. Remember we talked about, MOSFET, transistors, and how zeros and ones are represented in terms of voltage. The other class, CISP 440, is pretty much a math class. Okay, that's all it is about. Conjunction, disjunction, all kinds of logic, probability functions, and stuff like that, which is kind of fun to teach. And according to Mr. Fox, after the curriculum was changed, it has not been taught before. So this is the first time we teach it, using the new curriculum, the new way of structuring the material. All right, so as far as this class is concerned, the first thing we'll do is to go over the homework assignment that was due 3 minutes and 35 seconds ago. Are there any questions about that particular homework assignment? Sorry? What homework assignment?
Yep. You said it doesn't have to be optimized, right?
It does not have to be optimized. I would build it to be flexible, okay, so that it's easy to make changes to it if you need to. I just took a glance at what people turn in, and a lot of people would use a compare long, to compare like 4 bytes all at the same time, which is okay. I mean, that's not a it's one way to do it. But a more general approach is to compare byte by byte, because when you compare byte by byte, it makes it easier to generalize the algorithm for your next homework assignment. All right. So what we'll do is, if you want to, okay, I'll do this. I'll defer to the lab time to implement my own, bunny hunter. Okay, so I'm not going to use up today's lecture time to do it. So for those of you who are going to the lab to do the next homework assignment, I'll be, going over the bunny hunter and, how I would do it. But but what we'll do today is to go get started on the new homework assignment, which is called a substring, program. It's called str because that's the C++ function to do the same thing. Okay, the instruction of this is actually deceptively simple. Okay, string is a C++ function that locates a substring. You can refer to the man page for more details. And you will see this type of thing a lot when you are writing programs or writing subroutines that are well documented. So I'll refer to that man page in a second. The rest of the instructions says you'll create a folder called str or string and place the source file string.s in it. Use the following as a template for your implementation of string. So for this part, you can pretty much just kind of copy and paste and put it into your program as a starting point. I'll just go ahead and go over a part of this. The first part is I switched to the data section so that we can allocate storage that can be overwritten. Kind of like the .fill part of your current homework assignment. We have one label called haystack, and we have another label called needle. And you don't even need to refer to these label names when you get into your subroutine. I'll explain later. Each one has exactly 256 bytes allocated. And then we switch back to the text section. .global start exporting the label _start, and _start needs a colon after this. So I'm hoping that you guys will remember to fix it, because otherwise the assembler will remind you. And this code is already provided here. Okay, I copy haystack as a label into EAX. I copy needle as a label into EBX. Okay, this is what I'm doing. Okay, you don't have to do this part. what you will have to do is to put your code after these two move long instructions to implement string or finding a substring inside the string. In your code, do not refer to the labels haystack or needle because you want to rely on EAX and EBX as quote-unquote parameters to your code. Is everybody understanding what I mean by that? Okay, so there's no need for you to refer to the label names at all. Okay, so do not refer to the label names. Make use of EAX, which is initialized to a pointer to haystack, which is the beginning of a string to be scanned, and EBX, which is a pointer to needle, which is also a string, but this is a string to be found within the haystack as parameters. The return value should be placed in EAX. So this is a good time to switch to the man page of cisp310. And you can do the same thing with your own virtual machine. It should pop up the same way as with this particular live distribution because they're all based on the Debian distribution and have all the basic standard packages installed. So this is the documentation. This is the man page of cisp310 or string, which is to locate a substring. We are only going to use the first one, which is case sensitive. Okay. And the description is string function finds the first occurrence of the substring needle in the string haystack. The terminating null character are not compared. So in this case, we have to be careful because the first thing is when we talk about a string, it is going to use the same standard as in C and C++, which means a string is basically an array of characters that is null terminated. Does everybody understand what I mean by null termination? Yes or no? Yes? Okay. So so this way you have to so using a null termination string, you know when to stop scanning. It's like, okay, we have hit the end of one string, it's time to stop. Okay. Right here. The return value, okay, this is the important part because I want EAX to conform to the return value standard of cisp310. These functions return a pointer to the beginning of the located substring or null if the substring is not found. Okay. One thing you can do if you're not 100% sure what cisp310 does, what you want to do is to compile a very simple C program just to observe what it does. Okay, which is what I'll do next. All right, so let's go ahead and write and I think it uses string.h as a header file. So what I'll do is I'm going to make a sample program just to see the behavior of cisp310 in this regular C program, so that you know what your program is supposed to do. Okay, so we'll go ahead and write test1.cpp. Or just .c is fine. This is just a regular C function. It does not need to be C++. I'll include string.h, and we have main here. And we'll go ahead and have haystack initialized to the following. We are money hunting again. Okay, so that's one string. It is null terminated, and then the needle, which is the pattern that we are searching in haystack, is going to be, well, let's try B-U-U-N-Y. Okay, bunny, a misspelled version of bunny because it is not supposed to be found. Okay. All right. And now we're going to have another char pointer. So we have const char result here. So we'll just store result of str, and obviously I cannot remember which one is the first one, which one is the second. Okay, well, just in case you encounter the same problem, without exiting from VI, you can actually go to the man page. The trick is to do a colon and the exclamation point to shell out, and you can say man cisp310. And in this case, the haystack is the first parameter. Okay. So So we supply haystack as the first parameter, and then needle as the second parameter. And that's my entire program. All I really want to do is to test what stir is going to return when the substring to be found is not in the actual string. Is that okay so far? Are there any questions about what this program is going to do? Well, according to your understanding of the man page, what do you think result should end up as? 0. Should be a null point. Okay. Well, we'll give it a try. GCC-G-O test1 test1.c and GDB test1. So we put a breakpoint on line 11, run the program, and print result. Result is a null pointer. All right, which is expected. Okay. So let's go ahead and change the program just a little bit so that the string that we are supposed to find is in here. So we'll fix the spelling of bunny back to bunny, recompile the program, go back into GDB, put a breakpoint on line 12, run the program again, and this time when I print result, it is it's pointing to the place where bunny starts in haystack. So are there any questions about what stir is supposed to do? Now we haven't really talked about subroutines yet. Okay, so we haven't talked about call, return, let alone how to pass parameters, and that's why we are doing everything with registers. EAX is the haystack or the first parameter. EBX is the second parameter, and then we reuse EAX as the result of the function call. Are we doing okay so far with this code? Okay, so here comes the second question. The string is going to be null terminated. How do you create a null terminated string using a file so that you'll be able to restore that into a chunk of memory in a program? Because that's what you need to do in order to test your program. Is that making any sense? Now, one thing you can do, or you can rely on, is .fill is automatically filling up a chunk of memory with all no bytes, right? So if you load a file, or if you load the content of a file into that chunk of memory, it will use up as many bytes as the length of the file itself, but the rest of the bytes will still be null bytes. So that's one way you can kind of specify the null terminator. The other thing you can do is to actually put a null byte into a text file so that when you load the text file into the memory of your program, it automatically has the null terminator. Okay, let's go ahead and look at the second approach and see how we can do something like that. Okay? All right. All right, so what we'll do is we'll look at like a few test cases, and I will say haystack.txt or haystack1 for test case number 1, and you can say Bugs Bunny is rather busy today. Okay, so this is the haystack. Okay, this is the string to be searched, to be scanned, and to let you know for sure that the null terminator is not here, what we'll do is we'll use hex dump as a program and use -c to print characters out. And haystack1.txt. And you can see how the content of a text file, you can do this with a binary file as well, okay? But with a text file, you can actually see the ASCII characters individually in this file. And you can see 42 is the first byte. 42 in hexadecimal is the ASCII code of uppercase B. The next one is 75 in hexadecimal, which is the ASCII code of lowercase u, and so on. There are no null terminators. Okay? So what we want to do is to be able to add a null terminator, and the last byte is a 0A, which is a line feed character. It marks the end of a line. Okay. But that's not useful for string because string is supposed to work on no terminated strings, not line feed terminated strings. So what we'll do is we go back to haystack 1, and the very end here. Now this works in in VI. I'm not really sure whether it works in Nano or not. Okay, so I cannot be sure about that one. So if you type Control V first, then the next thing you type is going to be a control character, and it will just give you the control character verbatim. The null string or the null byte is also known as control at. So if I do a control at here, you cannot see it. If I backspace a little bit, you can kind of see it. It's in dark blue at this point, but there's a caret symbol and an at sign, which is the null terminator. Okay, so we'll save the file as it is now, and just do another hex dump, and you can see that we do have a null terminator now. So Control V followed by Control at, and the at sign is the way you enter a null character into a text file. Are there any questions about what I just did? Yeah, I did it in Vim. You can try to do it in Nano. I'm not really sure whether Nano can do it or not. So we can try a Nano test.txt, give it a bunch of gibberish, and go back a few times. Go to Control V. Now Control V has a different meaning. It does not do the same thing as in BI.
You know that text editor gedit or gedit?
That may not be able to do it. Most normal text editors cannot let you enter control characters. VI is kind of like a programmer's editor, and that's why it has special functions to do that. Let me see if I can do something here. You can probably install a different program with your virtual machine to do it too. I think there's a hex editor program called hex edit. So if you go ahead and install this, that might be able to do it. So to install the program, you have to go to the root account first, and then you just type aptitude install hex edit, which is the name of the package and also the name of the program. You don't have to do it this way, okay? If you know how to use VI, I would just use VI to do it. But if you want to, be able to edit a program in hexadecimal, this is one quick and easy way to do it. So you can say, let me get out of the root account first. So you can say hex edit, and then whatever file that you are trying to edit here. In this case, it's test.txt. And now you can see, it looks kind of like hex dump, but it is actually more than hex dump, because in addition to being able to view the individual bytes in hexadecimal, you can go to a particular byte location. So let's say I'm going to this location here. You can overtype it, you can overwrite it with 00. That makes it a null byte. Okay, so, and then you have to be able to save it. I'm just going to assume that, let's see. I just press the escape key, doesn't do a single thing. Unknown command, press F1 for help. Okay, good. So press F1. Oh, okay. The F1 is captured by the terminal program itself. It's not getting passed through to the program.
The control key, like can you control it?
Well, if all fails, we can just do it this way. There we go. All right, so I think we have a whole bunch of keys here. F2 to save the file, and Control X to save and exit. There we go. Get back into here. Control X, save changes. Yes, no, cancel. Yes. And now we can double check. Okay, this time I'm going to use hex dump to double check to make sure that my null character is actually saved, and it is. So are there any questions about using hex edit to change the content of a file so that you know for sure that you will have a null terminator in whatever string that you're loading. Any questions about this? Needless to say, hex edit and also hex dump are real basic tools for any hacker. It's like a screwdriver. Any questions? No questions? Okay, how would you get started with this particular homework assignment? Let's take a look at the description again of the program here. Well, okay, I actually did give you a little bit more pointers here. To start off with this program, write stir in C and C++ first. In other words, what you want to do is go back to the program that I wrote earlier, test1.c, but this time take out the pound include. Okay, so you're not going to use the library's own stir. Instead, use your own. Okay, so write your own subroutine: const char star stir const char stir haystack const char star needle, and write your own code here in C, okay, in basic C, so that you can get the algorithm right first. Okay, once you can get it done in C and C++, then you convert it into assembly code step by step. How many people remember how to convert a C program step by step into assembly code? Okay. We talked about it before the break, but since it's before the break, about 70% of the class is forgetting. It's like, what did we talk about before the break again? Well, we talked about how to convert C code into assembly code. Now, you can do a lot of stuff in a regular C program, okay? I would not stop until you turn the program into all ifs and go-tos and labels and flatten the entire program until the point where, okay, I can do no further translation. Then you start with your assembly code. Okay? So I'm not going to stop, just like making this work with, embedded while loop, because that's basically what you need is an embedded while loop. Don't stop there, okay? I would not stop until, it gets to the form where, oh, okay, I look at this code, all the conditions are simple comparisons, okay? And the only thing you do with any type of conditional statement is a go-to and has labels all over the place, okay? At that point, you can convert it into assembly code and keep the names of the labels. And because you can test your program in C much more readily than a program that is written in assembly, it makes it easier to debug the program, to debug the logic of the program. Does that make any sense? Sort of? Okay. All right. So you have 1 week to work on this particular homework assignment. I don't think it will take you too long. You might even be able to find, algorithms for stir if you need to. I don't think that would be a good idea because at this point, you should be able to come up with the algorithm yourself to find a substring within a string. But if you need to go find, the algorithm to do it, I might even help you do it. Algorithm stir. And let's see, Stack Overflow is not really the best way to do it. Building a better stir. Well, what can I say?
The internet. That is the internet.
I mean, it's done. I mean, but I think this is more complicated than it has to be. So you guys kind of have to decide, how you want to do it.
Well, he's saying that's the basic.
Okay.
Probably goes on to making a better way of doing it.
I would try to do it, yourself first. Okay, if I were you, I would try to do it myself first, just to. So that
Hey, you don't want to put that on
holy
camera.
smokes!
You don't want to put that on camera, man.
Well, I'll be able to tell quickly.
What was the name of that one?
Let's see. Implement stir to find the substring in the string. Yep, there you go. Okay, so here's another code written in C and C++. Okay, so take your pick. I wouldn't do anything like that. This is just plain ugly. Putting a return statement inside the conditional statement that is in a loop. I would never ever do anything like that.
I'm terrible. I think I had that line in a
Sorry?
Like it's not that program.
Well, that's a philosophical kind of thing, but personally, I don't even like having a return in anything other than the end of a function.
But so then,
it makes it difficult to analyze your program. That's basically what it is. Okay, if you look at this particular program, okay, let me just magnify it a little bit first so everybody can see it. Okay. So when you look at this program, what I typically do is I would examine this code and say, okay, if I get out of this loop, what does it mean? Okay, and according to this, the only reason I can get out of the loop is when whatever P1 points to is a null. Okay, and that's how I can get to the code or the statement after the while loop. But if you have a return inside, like this one here, then it just breaks my analysis, because my analysis of, if I get out of this loop, that analysis is still correct.
yeah.
But the question is, but now we have a different way to get out of the function itself. And that's usually not a good way. Because when the program is simple, it's still easy. You can spot the return inside the while loop, inside the conditional statement, inside the while loop easily. But when this code gets longer, sometimes you will miss that one return inside a loop, and you go like, well, what is this loop supposed to do? When do I get out of the loop? It makes it harder to analyze, the structure of the program.
It's kind of these things are wrong. It's kind of on the same subject.
Yep.
So a function that has a void return, right? If in there the last line of code is a call to another function, does it come back?
Yep, it does.
It has to, right?
Yep. There's no tail end recursion in C and C++. So every single function call is a true function call where it will go and then come back. Yep.
Oh, because there of that whole, there's a return address on the stack.
Because there's a return address on the stack. Correct. Yep. The other thing that I don't really like about this coding style is that there are no open and closed curly braces for the then portion of the conditional statement, the one that I'm highlighting here. That there are no curly braces, which means if there's one extra thing you want to do before the return, and you put that one line of code before the return, it will break the logic of the program. It's not breaking the syntax at all, it's breaking the logic of the program. So I personally really look at this code and cringe a little bit.
Yeah, that chart line, that chart line does look pretty hideous.
Yep.
So even when you only have one line in a condition, you still think it's a good idea to put curly braces?
Just in case later on you want to add additional code.
Okay.
Because otherwise, if you only have one line and you don't have the curly braces, and later on you decide, hey, I need to do one more thing before the only line that you have in there, and you insert just that line, and you have been programming in Python for a while, and this thing doesn't click. Then it will change the logic of the program. It's not a syntactical issue, because whatever you're inserting into the code becomes the only part of the then portion. And it pushes the original statement out of the conditional statement, so it becomes sequential to the conditional statement. But syntactically speaking, when you look at the indentation, it suggests the wrong, structure. And that's why I personally really do not like that.
Okay.
But that's a personal thing. I have been bitten by this one for way too many times, and that's why I always use your curly braces.
Nice.
Yep. Alrighty. Well, so there you have it. Okay, sample code that you can rely on to implement your string. But I would try to do it personally first. Okay, just so that I would understand the logic. Because if you look at a piece of code like this and you try to convert it into assembly, and you make a mistake somewhere, it would be pretty hard to debug it if you don't know how it works to begin with. But if you start off with your own code that you came up with, then when it doesn't work, oh, okay, it's because of this. Okay. Are there any questions about string? There are no shortcuts in life. The only shortcuts, typically would go downhill or into a hole somewhere. No questions about all this stuff? You guys got a pretty... Yep, go ahead.
So on the homework assignment, are we going to be using the stack? On the homework assignment, are we going to be using the stack?
No, not yet. Well, what do you want to use the stack for?
Well, I think you're putting like haystack into EAX or something.
Just the label.
Label.
Yeah, the label is in EAX already.
You don't need to
So you don't need to refer to the label itself.
Yeah, but you don't need to pop out the stack so that you can use EAX.
No, you can use all the registers that are available to you. So EAX, EDX, ECX, and EDX. If you need additional quote-unquote variables, you can just allocate a .int with a label, and then you can use the correct operand to access it. I don't think you will need that many things. You don't need to keep track of that many things in your program, because in this code here, we can see that we have the two pointers, P1 and P2, and then you have to save P1 begin because you have to restore to a certain point. So you use one register for that purpose. And other than that, I cannot imagine why you would need more than 4 registers.
There should be more brackets. There should not be all that.
Yeah, this is I don't like this coding style. That's why I'm showing it to you. Yeah, try to use this one. Yep. Are there any questions about this code? Yep.
Yeah, so EAX is just taking the address where it starts to begin, the substring begins?
Mm-hmm.
Okay.
Yep. That code is already given to you, so this is the beginning of your code. So EAX and EBX will be initialized by the time it gets to your code. So EAX points to the beginning of the string to be scanned, and then EBX points to the beginning of the string that is the search pattern that you need to find. Okay. So this is kind of like a generalized version of bunny, to search for the word bunny, except in this case we don't know even how long the substring is supposed to be. Any other questions about this? Go ahead.
So basically the needle, the way it's going to do it is since you suggested we use only 8 bits, then it's going to compare character by character through.
You will be basically comparing character by character, and you will keep comparing until you find a mismatch. When you find a mismatch, you have to go back and say, oh, okay, this is not working. Then you have to advance the pointer to the next location and then do the same thing again. And that's why you typically will need a double loop to get this done. There are ways to use a single loop to do it, but it's it's pretty awkward to use a single loop to do it. Yep.
Just based on the architecture, though, you can kind of see how long the string could possibly be, yes?
You don't want to rely on that. Why do you think you know how long the string can be?
Well, if you're only using 256 bytes, correct?
Well, it all depends on how I'm loading up the content in memory, right? Because I can load it up so that I can use up, let's say not 700, but I can use up maybe 400 bytes from haystack, and instead of starting the search pattern at exactly needle, I can do it like needle plus some offset, because your code is not supposed to know, other than EAX and EBX, where is the first byte of the haystack and where is the first byte of the needle.
That's why we need the terminator. We're not counting the 255 or 256.
You don't want to rely on the 256, 256.
Terminator.
Yep. You want to rely only on EAX and EBX as the starting point of both of those strings. Yep.
What would you want us to do if there was not a null terminator?
You would do what string would normally do, which is the wrong thing. It would keep going. Well, the way it's structured, with haystack first and then needle next to it, means that it will terminate. Even if haystack is not properly null terminated, haystack will run into needle, and since you're searching for the subpattern of needle, it will find itself, as long as needle itself is null terminated.
Yeah,
Okay, think of it this way.
Yeah, I was thinking of the needle is what we're looking for, right?
Yes.
And if needle was not null terminated,
If needle is not null terminated, then you might end up with a situation. Okay, if haystack is null terminated, it will still be okay. Because if haystack is null terminated but needle is not, then you will still have a mismatch and say, hey, I'm already at the end of the haystack and I cannot find the pattern, or I cannot find the entire pattern. And then you just say, okay, the needle is not in the haystack because the needle is actually bigger than the haystack, which is a really weird picture. If both of them are not terminated, then we might have an issue, because then it can keep going and going and going. But it still relies on the self-repeating pattern, because remember, when you're looking for a pattern match, the first time you see two bytes that are different, you stop and say, hey, it's not there.
I was thinking of process. I was needlessly thinking of processing and finding how big it is.
Yeah, so to test your program, you can be guaranteed that the test cases that I'll be using will be null terminated.
Okay.
All right. Any other questions? So your code does not have to behave any more or less compared to the C code that implements string. Any other questions about this program?
While we're coding, if we get any sort of question, we can just sort of look to the behavior of the string function and see.
Yep.
Okay.
Yep. Absolutely. In fact, I would start with that. Yeah, I would start to think about test cases first, and then use the test cases on the actual string function to find out what it's going to do for those particular situations. So that way you have an idea of how to format or how to come up with a logic of your own string function. Question?
So say we wrote well, not say we write this in C, and then we just give GCC the S switch, so it just compiles the assembly. Now,
Don't do that.
Yeah. No, I'm not saying that would be like what we return it. I'm
Right.
just saying just for seeing what's going on, like to see how it turns that into assembly. Is that any benefit? Because sometimes when you do that,
It will give you instructions that we have not talked about in this class, so it may not be that beneficial. All right. Any other questions? Yep.
You said we could assume that the test cases would be null terminated?
Yes. Yes. So both haystack and needle will be null terminated. So I won't give you cases where they are not null terminated. Okay, so since I knew what George was going to ask, I specifically have this statement here to say that your submission must reflect your, in italic, your own skill and competency of writing code in assembly language.
the ability to use the switch.
Just put after George.
George.
Whoa.
No, what I really should have said is your, and then in parentheses, singular. Yeah, because your can be plural
exactly.
in English.
Absolutely.
Yes.
Me and GCC.
Yeah. Don't make this a collective effort. Okay, write your own code. Any other questions? Yep.
Not completely related to this, but if you have a, say like a move, whatever length, long byte with word, and you have two registers and you want to move the value of one register into the other, but you want to increment it volatilely so you don't modify the content, and that whatever math you applied right there is then moved into the other register.
Okay, so you want to perform a calculation of some kind.
Yeah, on of the content of the register, then place it into
A second register, another register.
Yes.
There are several ways to do that. It depends on what kind of calculation we are talking about.
Let's say just
Adding
simple
one?
addition, like add one to
Add one?
that,
Okay.
that value, and then put it into
Okay,
this
so
other.
so let's say you have EAX as the original register that has a value that you want to add one to,
Yeah.
but you want the result to be in, let's say, in ECX. Okay, so the way to do it, or one way to do it, the way I would do it, is to do a move L EAX to to ECX first. Then you can perform your whatever calculation you want to ECX, right? So it does not change the value in EAX, and the EAX plus 1 will now be stored in ECX. So assuming I'm understanding your question, this is how I would do
equivalent to
it.
that, but
Right.
in one line.
In one line.
Yes.
There's no way to do it in one line.
Okay. Well, I was noticing that you can do you can add to a constant, but register it wouldn't work.
No, you have to. There's no way to do this in one single instruction.
Okay.
Yep. Alrighty. Any other questions about this? No other questions? All right. Let's see. Well, we have about half an hour left, a little more than half an hour. So this will be a good time to get started with the practice test for exam 2.
Really good.
Well, I stored it on my Google Drive.
Oh, yeah.
Okay, this is exam 2.
Yeah, I'm actually, I like it.
All right, so for exam 2, the first question is express JAL1, but only using JC, JZ, and jump instructions. Well, you can also define as many labels as you want. Okay, but you cannot use JNC or JNZ in this case. You can only use JC, JZ, and jump. And I want to implement JA.
Yeah.
So the first question is, what is JA? Well, that's why it is open book and open notes. So you can print out my notes and bring it with you. JA is jump if above. Okay, but that's in the unsigned interpretation. Otherwise, it would have been JG for jump if greater than. Okay, so JA is jump if above. Okay, so if you think about it, so let's say I have a JA instruction here to label L1, and I have some additional code over here. I don't really care what I'm doing here, but we have a label L1 here. What does it mean when I get to L1? What, in terms of the configuration of the flags that we have talked about, the 4 flags that we have talked about. So we'll go ahead and examine every single flag individually, and you can tell me, well, we don't care about this one. Oh, this one has to be a 0. That one has to be a 1. Okay. So we'll start with the sign flag. Okay. What do you think the sign flag needs to have by the time we get to label L1? Well, first of all, is this a signed type of interpretation? I just said it, right? Okay. So if it's not a signed interpretation, this can be whatever. Okay. We don't care. Same thing applies to the overflow flag, because overflow only has meaning for signed numbers. JA is an unsigned interpretation, and as a result, the overflow flag can be whatever. Okay. What about the carry flag?
It should be set.
Okay, so a JA instruction typically is after a compare instruction. So we have compare, and then we have some number y and some number x here. So this is basically saying if x is above y, go to label L1.
So which would be 1, x minus y, so then no carry flag should not be selected.
So what do you think should be in the carry flag?
Zero.
Should be clear. Correct. And what about the Z flag?
Well, it can't be zero. It has to be zero. If it was
Well,
zero,
if
then
it
it'd be
is,
false.
if the carry flag is a 1, what does it mean?
That they were equal.
It means they are the same. It means y and x are the same.
So that needs.
If they're the same, it is not greater than, so we need the Z flag to be clear as well. Is that making any sense? Okay. So this means, whatever sequence of instruction we are going to replace JA with will have to accomplish the same thing. It will only go to label L1 if and only if both the carry flag and the Z flag are cleared. But you're not allowed to use JNC or JNZ. You can only use JC, JZ, and a regular jump instruction. So how would you do that? It's actually easier that way.
Yeah. You just put that code underneath the line.
All right, well, let's think about it. Okay, so we'll expand this line of code, one single instruction, into a series of instructions. And since you're only allowed to use JC and JZ and jump, does it make sense to try to use JMP first? No, because that's unconditional, right? That's going to jump anyway. Okay, so that means I can use either JC or JZ to start with. JC means, if the carry flag is set, where should I go? L1?
No, you should.
Just go to a continuation point, right? So we have a continuation point here. JC just goes to the continuation point. Okay? If it does not jump because the carry is set, we will get the second instruction, right? Kind of makes sense to use a JZ here. Where should I go? Same thing, same place. Go to the continuation point because I don't want to end up at L1. What do I do next?
Jump.
Unconditional branch at this point, because by the time I get to the JMP instruction, it means the carry flag is cleared, the 0 flag is cleared as well. That is a double confirmation, right? Because we need both of those to be cleared. So at this point, we have the confirmation that we can continue onto L1. So that would be the correct answer for question Q1. And obviously, these two instructions can interchange. You can change the order. Doesn't really change the meaning of this chunk of code.
Because this is like an and. It's like an and where basically both
Correct.
upper and have.
Yep. It's an and, so you're checking for the negation of each one and say, if the negation of the first one is true, we continue. And then you check the second one and say, if the negation of the second condition is true, we also get out. All right, very good. So Q1 is done, and we'll look at Q2. The Q2 is what you guys like the most. It's about the double precision floating point number representation. Okay, this is what it's asking. What is the value represented by the following double precision floating point number that has the following binary representation expressed in hexadecimal? Okay, I just don't feel like spelling out 64 zeros and ones. Okay, that's why I'm using hexadecimal. It only takes 16 digits to do it. All right, so what are you going to do about this one?
Break down that.
Well, the only thing that matters would be the first 12-ish, bits, right? So let's make the first 16, the most significant 16 bits, because the rest are all zeros. Okay, so we don't really need to deal with all the zeros in this case. Okay, so the first thing you need to do is to do the actual conversion of Bff 8 into binary, right? B is 11. Oops. Come on. I hate this. Cordless mouse is doing something it's not supposed to. All right. So B is 1011. F is 1111. F is 1111. 8 is 1, 0, 0, 0, and then the rest are all zeros, okay? Which is not important to me. Is that part okay?
Yes.
If you cannot remember, like, if you cannot do base 16 to base 2 conversion by heart, what are you gonna do? It's open book, open notes.
Yeah.
So write it down on a piece of paper somewhere. Okay. You can even put it on your palm. Okay? You can write on any body parts. That's okay with me. As long as you don't end up, doing any type of exposure issue. Well, gotta cover that part. All right. So now that we have this representation, now we break it out into the sign of the number, the exponent of the number, as well as the mantissa or the fraction of the number. Okay. So we'll go ahead and say, okay, this one is the sign. The exponent is going to be the next 11 bits, which is 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. That's the exponent. And then the rest is the fraction. Okay, so this is the fraction. So I'll just use extra spacing here just so that it is clear which portion is which portion. Are we doing okay so far? Okay. But how can I remember, the sign is here, and then the next 11 bits and not 10 or 12 bits is the exponent and so on? Well, that's why it's open book and open notes. Okay, you can bring it with you. If you want to print out the entire Wikipedia page on floating point number representation, bring it with you if that is going to be helpful to you. All right, so now we look at this number here and say this is a -1, okay, because it's a negative number. The exponent is all ones, okay, and there are 10 ones in here, okay, not 11. So that will make it what?
You said the exponent is all ones. What's that?
Sorry?
Isn't there
There's a zero.
That's a 0.
1023.
So
Well,
That's 1023,
Yeah.
right? So that is exactly 1023, and the rest is just a 1 followed by all zeros. Okay, but you have to be careful about this 1023 because this 1023 is not 2 to the power of 1023 because everything is offset by exactly 1023. So the actual exponent that we're dealing with is 0. Okay. So this tells me that we are dealing with 2 to the power of 0 as an exponent. Is that okay? That's the tricky part because I don't want people to tell me, oh, this is a big, huge number because it's 2 to the power of 1023. But this is a fraction, which means it is actually saying it is 1.1 in base 2. It is not 1 in base 2, it's 1.1 in base 2. The 1 to the left-hand side of the decimal point, or binary point in this case, is implicit, okay? So we are dealing with -1 times 1.1 in base 2 times 2 to the power of 0. So we only have one step left to deal with this conversion because 1.2 in base 2 is what in base 10? It's 1.5 in base 10. What is 2 to the power of 0? That's just 1, and -1 is -1. So this representation is actually just representing -1.5 in decimal. Any questions about this part? Yep.
So what'd you do again to grab the 1.1?
The 1.1 is, okay, this one here is this one here. This one is the fractional. But the other one, which is the one to the left-hand side of the decimal point, is implicit. It's always there. Okay? So are there any questions about the answer of Q2, which is 1.5 in base 10? What, -1.5? Yep, go ahead. It's because the exponent is 1023, this part here is 1023, but because it's offset by 1023, when you have a value of 1023 here, it means you have an exponent of 0. Okay. And for this particular question, if you review either your solution or my solution to the floating point number conversion program, that might help. That might be helpful because it has to conform to all of those standards. All right. Any further questions about number 2?
Remember you did the 80, but when we moved the decimal or the binary point to the left, we changed the exponent by 52 or something? Like in our A2F?
That's only when you do the conversion.
Okay.
That's only when you do the conversion because when you do the conversion, after all the calculations, especially after the division, the binary point is all the way to the right-hand side. So when you need to implicitly move the binary point 52 positions to the left, that's why we need to adjust the exponent by 52 as well. But in this case, it's the interpretation of a bit pattern, and we don't have to worry about that part. Question number 3 is observe the following code. We have a move byte instruction followed by add byte instruction. Provide a range of values for the missing value so the result has the carry flag cleared. All right. You had a question?
Oh, no, I was just mentioning.
Okay. So what about this one? I want the carry flag cleared, and I want you to give me a range of numbers that can get the carry flag cleared.
So that would mean, yeah, you want to add some number that will not exceed 255.
That is correct. Okay. Well, yeah, not exceed up to 255, right? So you can start with what? 0. Okay. 45 plus 0 is 45. Does not generate a carry. So you can say, okay, plus 1 is okay, plus 2 is okay, all the way up to, so the last one is going to be 255 minus 45, which is 210. Yep. So the correct range in this case is 0 to 210, inclusively. So if you want to be clear, you use square brackets, that's kind of like a math notation thing. When you use round parentheses, it is exclusive. When you use square brackets, it is inclusive. Okay, question number 4. The following code is supposed to find the maximum of EAX and EBX and then update ECX with the maximum. So I want to use EAX to store the maximum of EAX and EBX. They're all registers. It doesn't quite work the way it's supposed to, because of certain things that is wrong in this code. Oh, and I also wrote here, it is supposed to be interpreted unsigned. Okay, so EAX and EBX are supposed to be interpreted unsigned as unsigned numbers. But the question is, I don't want you to fix the program. I want you to find a test case where this program is going to fail. Specify the values of EAX and EBX for the test case where it is going to fail. So I'm not asking you to fix the program, which is the easier part of dealing with this particular question. I want you to think a little bit deeper and say, oh, okay, I need to find a test case where this is going to fail. What do you think? Okay, where is the problem? The first instruction is the problem, okay? Because I'm using compare word to only compare the least significant 16 bits of the 32-bit registers. Okay, so that means if you only make test cases up to 65,535, which can be represented only using 16 bits, the problem is not going to show up. Is that making any sense? So you have to make sure that you use a test case that will exceed that range. So I would pick 0x1 followed by 4 zeros as one number, and then use FFFF as the other number. They're only off by 1, but it will make the comparison fail. that making any sense? Because 1 followed by 4 zeros, if you interpret it as a 32-bit number, is 65,536. Okay. On the other hand, if you get rid of the most significant 16 bits, it just becomes 0. And that's when the comparison will fail and choose to use FFFF as the larger of the two. It doesn't even depend on which one is the one that has 1 followed by 4 zeros in hexadecimal and which one has 4 Fs, because the comparison will fail in either case. Is that okay with this particular question? So, just to give you what I would write down as an answer, so that you can write that down too. EAX, just gets 1 followed by 4 zeros, but it has to be in hexadecimal, because 10,000 as a decimal number does not get to the range of value that will trigger this to happen. EBX is 0xFFFF, that will make it fail. Are there any questions about number 4? No questions about number 4? Let's move on to number 5. Number 5, I give you a chunk of code, okay? This is kind of like the bunny thing, okay? Except it's the reverse. This is the easier way to do the original bunny program. Observe the following code, yada yada yada. When execution reaches the label, check here, what is the value in register EAX? Okay, so before I execute this instruction, what is going to be the value of EAX? Specify in hexadecimal. So so I'm actually requiring you to use hexadecimal to represent the end result here. Okay, what do you think? Well, let's go ahead and take a look at what is underscore start -4 and track down the execution of this program. So we'll start with the very first instruction here. The first operand is, what kind of operand is it? It's an immediate operand. Okay, it's not a direct operand, it's an immediate operand. In other words, I am actually going to find out what is the label underscore start, okay? Subtract 4 from the label underscore start, and then copy that particular value into EAX. What exactly is underscore start? It's the current location, but how does it relate to underscore start -11?
It's all octal 246.
Yep, exactly. Yep. Okay. So underscore start -4 is what? It is the address of the .int, right?
Oh, because it goes.
Because it goes back 4 bytes. Okay. So this is one thing that you have to remember is in assembly language programming, everything is contiguous. You can intermix assembly language instructions and .ints, .bytes, .words, .fills. They're all contiguous. They're all right next to each other. Okay? So there's no problem whatsoever, with this instruction. So if I were to write down a comment of what EAX is, after this instruction, I'll just say EAX is underscore start -4. Okay, that's the pseudo C code. Okay, I'm not doing any dereferencing here. Do you see that there are no dereference operator? I'm just calculating where's underscore start, subtract 4 from it, and that's what I will put into register EAX. Is that okay? What about the next instruction? Well, let's find out. The next instruction is going to say, it's basically doing the same thing as this, right? But treating EAX as a 32-bit, integer pointer. What is at that location? It'll be underscore start -11. Okay? So that means EAX ends up with the value of underscore start -11. Is that okay? I think I might have one instruction too many. We'll find out. Okay, what about this one? It is another dereference, right? Because it's what? How do we call the first operand in this particular instruction? How do we call it? Does it have a specific name? It's an indirect operand. Very good. Okay. So indirect operand is to use a register as if it is a pointer. Go to the location pointed to by the register and retrieve the content at that location. And on retrieving 4 bytes, put it back into EAX, which is perfectly okay. What is at underscore start minus 11? I think I have one too many instruction here, so I'm gonna have to delete this one here. Okay, this one is a little bit tricky because it is right in the middle of something. Okay, so what you want to do at this point is to write out all the bytes individually and then count to underscore start minus 11. Okay. It sounds a lot more difficult than it is.
A word is the same as an int, right?
Hmm?
A word is an int.
A word is 16-bit.
How long is an
Oh,
int?
no.
How long is an int exactly?
An int, a dot int is 32-bit wide. All right, so I'm gonna use a line of comment here to list out the bytes individually and taking little endian into consideration. So don't forget about little endian because you need to know with a multi-byte integer which one goes to the first byte and which one goes to the last byte. So I'm gonna look at 0x020246. Okay, the least significant byte is going to be the 46. These are all in hexadecimal, so I'm not even going to use the 0x prefix here. Okay, and then we have 02. Are we done with the first dot int constant?
Yes.
No. We're not done yet because we only have 2 bytes at this point. Remember, every single dot int thing has 4 bytes. So what about those 2 bytes that are not explicitly represented here?
Zeros.
They're all zeros. Like that. And then we have 2460. So we have 60 being the least significant byte which has the least, the lowest address, 24 being the next one, and then 2 implicit 0 bytes. Yep.
The 2 implicit 0 bytes go in front of the...
Nope, it's gonna be after because the implicit 0 bytes are the more significant bytes, and as a result, they are at a higher address. Yeah, yep, gotta be careful about those things. All right, so next we get to the first dot word, which is 246. Oh, that's, what base do you think 246 is in? It's decimal, okay? It doesn't have a 0x prefix, does not have a 0 prefix, which is octal, and without any prefix, it is a decimal number. With a decimal number like 246, how do we convert it into hexadecimal? There are several ways to do it. You can either convert it into base 2 first and then convert it back into base 16, or you can do it directly. I'll show you how to do it directly.
255 minus.
You can do it all directly too. You can just do it division by 16, okay? So we have 1 here, and that will give us 5 here, right? With a remainder of 6. This is the least significant digit, which is a 6. A 6 is a 6. This is the most significant digit, which is F. So it's the same thing as a F6. Is that okay? Okay, all right. So it's a F6, but that's not enough to fill in 2 bytes. I need to give it 1 extra byte of 0. Now the other way to look at the F6 is it has 6 ones and F many 16s. F is 15, so it has 15 16s. So that's why the division, way to do it will work. Okay. It doesn't really. It's really tedious when you get to really large numbers, but anything that's less than 256, pretty easy. Okay, the next number is 0246. The 0, because it starts with a 0 without an X, it means it's an octal number. Okay, these are all standard C notation. It's not unique to assembly language programming. So with an octal number 0246, what does it look like in binary? Well, each digit is responsible for 3 bits in this case, right? So how do we represent 6 using only 3 binary digits? Okay, what about 4? What about 2? And remember, we have to use exactly 3 bits. 0, 1, 0. Very good. Okay, so now we know the binary pattern that we want to represent. We regroup in 4 bits, okay? So 0, 1, 1, 0 becomes one base 16 digit, and then this becomes the other base 16 digit. So we have a 6 here, and then we have an A here. 1010 is A in hexadecimal, 0110 is 6 in hexadecimal. So now we have A6 as the least significant byte, and we have a more significant byte of 00 in this case. Are we doing okay so far with all the base conversion stuff? And that's it. Well, we have another .int here, but we have no idea of the content of that .int because it all depends on where underscore start is, and we don't really know where underscore start is going to start. So we'll just put in question marks here. And then we have the actual underscore start label. So underscore start is actually at this location, which is which is the first byte of the move L instruction. Are we doing okay so far with this part? Okay, so I'll just go ahead and change this to a move L, and then I'll say this location is underscore start. So knowing that underscore start is the address of the byte after the last question mark, can we figure out what is underscore start minus 11? Well, it's just a matter of counting, right? Just a matter of counting. Okay, so we'll say this is underscore start minus 0, minus 1, minus 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That byte is corresponding to underscore start minus 11. But what I'm doing is I'm loading 4 bytes starting at that location into EAX. So what I'll be doing is I'm going to copy 240000 F6. These 4 bytes will be copied into EAX. Now whenever you copy multiple bytes from memory into a register, you have to remember little endian, okay? And that means 24 is going to be the least significant byte, and F6 is going to be the most significant byte. So the correct answer in this case is F6 000024. Are there any questions about this? Yep.
How we pointed to the underscore minus 4? Where is that value?
Those are the question marks. Because we don't know the exact bit pattern, so I'm just going to use question marks to represent it.
So which is we go back to 4 bytes from the start underscore start.
Yeah. The .int underscore start minus 11 is represented by the 4 pairs of question marks. But underscore start minus 4 is not represented anywhere in memory. It is just a part of the instruction.
Wouldn't those question marks be 240000 F6?
The question marks?
Yeah.
Nope. It's going to be the address, right? And
Okay.
since we don't know exactly where the linker is going to put the program, we cannot determine that.
So what value will be in at the location what EAX value?
So after the third move out instruction, EAX is going to be 0xF6 000024. The good thing about this program is you can actually run it. You can type it in and run it, and if it doesn't come up with this correct answer, you will have to let me know. I'll give you your money back, guaranteed. But are there any questions about the concept involved in this particular question? There are really quite a few concepts involved. There are some base conversion, lead to endian, what is the width of an instruction, what is the indirect operand, so it's a combination of concepts that you have to kind of put together in order to answer this one single question.
Is it going to be more complicated than that on the test?
Well, it's kind of about the same.
Probably.
Yeah. I think one way to kind of guesstimate, the difficulty level difference is to go back to my previous year lectures, because I go over, every single test with a pretest, and then after the test I go over the answers too, and usually I record both of them, so you can actually do a comparison and go like, okay, how different is it going to be in the actual exam?
Well, it's a simple conversion factor. Like take the complexity of the pre-example and then just multiply by 5.
Well, that's what the George scale. Yep.
Now the value of what it was originally, you had 3 moves. EAX.
Yep. The third one, it will be unpredictable because it will try to go to location F6000024 and grab those 4 bytes, which most likely will end up with a segmentation fault. Yep.
Or can we find this file? Isn't this file unlisted?
I can share that with you.
Is it uploaded?
Yeah.
It's not shared yet. I have to share it. So I will share with anyone with the link. Copy this. Go back to Google site. And I'll stash it into the assembly language programming section. Into here. So this is going to be a URL. Sample questions of exam 2. Does anyone want to test it?
Oh, everybody got
Oh, I can see several people testing it right now. Yep, go ahead.
For the homework.
For the homework.
Function like string function we can call and pass the to parameter, then we return the value.
You are this. Well, since I have not talked about how to implement subroutines yet in this class, so you're not going to use a function. You just put your code in, after the underscore start.
So we can do loop just under the start.
Yeah, just do whatever you need to do. I'm not suggesting that you have to use a loop.
Yeah,
Very
we
long.
can print the
Right?
character
No,
with
that would actually be way harder.
Yep.
Because then you have to
Go ahead.
How would you do recursion using assembly language?
You call? It's the same way. Doing recursion in assembly is the same way as you do in C and C++. The tricky part is, what do you do with the parameters and what do you do with the local variables? We are not quite there yet, but we still have about 5-6 weeks left, so I think we'll be able to cover all the material this time. Last semester, I did not quite get enough time. Yep.
Was that the last question?
The last question, yeah, that was the last question of the exam. The last one that I prepared. I will probably, most likely, I'll have a question number 6, which is going to be in the form of giving you the C code and then giving you the assembly code that implements the C code, but it will be erroneous. And your job is to find out how it is wrong and fix it.
In assembly or
In assembly. So the C code, there will be a chunk of C code, and I'll give you my version of assembly code to implement the C code. So I'm going to do the translation, but the translation is going to have an error of some sort. and then you will have to figure out, oh, okay, this is wrong, we have to fix it here, and this is also wrong, we have to fix it here. And you cannot just rewrite it. I know most of you want to just say, oh, I'll just go ahead and rewrite the whole thing. No, you cannot. You can only identify which part is wrong and fix it.
Can you write things in more similar case, which is assembly code, we just return to the C code ourselves?
Can you re-ask that question?
In my question is, can you write some C code which is more similar to which you give us so we cannot do much this practice? So in case we can practice, just turn the assembly code to C code, we can practice this one.
You can practice with.
Yeah, the same, more similar stuff.
Well, I cannot answer that question because I have no idea what I'm going to ask in the actual exam. my crystal ball is kind of cloudy right now. You have to understand the material. That's the whole point. Is you have to understand every single concept crystal clear and be able to apply those concepts in the exam. That's the only way to prepare for the exam. Yep. The exam is 1 week from today. Well, 1 week from today minus 80 minutes. Because I don't want people to argue with me and say, but you said it's 1 week from here and now, so it's going to start at 8:20. No, it starts at 7 o'clock.
We'll consider that lab time.
I feel
Yeah, or we can chew into lab time, right? Yeah. Alrighty. Any other questions? If there are no questions, I will go ahead and implement the homework assignment due today in the lab. And also, potentially, I will go grab some other random string functions and do it in assembly. Well, something other than string.